This is page 342. Number 1, a boat rental shop rents paddle boats for a fee plus an additional cost per hour. The cost of renting for different numbers of hours is shown in the table. You can see the first variable is time, and it goes from 0 to 1 to 2 to 3, and the second variable is cost, and it goes from 10 to 11 to 12 to 13. Number 1 reads, what is the independent variable and what is the dependent variable, and how do you know? Well, which one would depend on the other? Well, one of these things will happen regardless, whether you don't even rent a paddle boat. Time will pass. So time is the independent variable. And cost is the dependent variable. Because the cost, the reason why I'm doing it because here is because they ask us the second question. It says, how do you know? Because the cost depends, this is the most important part, the last line here, on the number of hours. The longer you rent it for, the more the cost is, which means the cost depends on the number of hours. So I'm going to read that with you. Time is the independent variable and cost is the dependent variable because the cost depends on the number of hours. All right, let's move on to number 2. Number 2 reads, a car travels at a constant rate of 60 miles per hour. Complete the table. Well, at 0 hours, the distance would be 0 miles. At 1 hour, it would be 60. At 2 hours, it would be 60 times 2, which is 120. At 3 hours, it would be 60 times 3, which is 180. B says, what is the independent variable and what is the dependent variable? So the independent variable doesn't ask us to explain why, so I'm just going to do a simple answer. And the dependent variable, the independent variable is time, and the dependent variable is distance. And if it asks why to explain it, I think that might be C. Let's check out C. It's not. If it asks us to explain it, it would be because the distance depends on the time. How far you go depends on how long you have to go. So the distance that you can travel would be the dependent variable. It would depend on how much time you have to travel. Question C says, describe how the value of the independent variable is related to the value of the dependent variable. Well, what do we notice about the y's? They're always what? This one is 60 times greater than this one. This is 60 times greater than this one. This one is 60 times greater than this one. The y values are 60 times greater than the x values. All right, good job. Number 2. Let's move on to number 3. Number 3 reads, the directions read, use the graph to answer the questions. Number 3 reads, describe in words how the value of the independent variable is related to the value of the dependent variable. Well, one thing we need to do is figure out the values here. It goes 1, 2, 3, 4, 5. And what's happening on the y-axis is it's going by 5. 5, 10, 15, 20, 25. So I go back to this and I start kind of from the origin and I say if I go over 1, I go up 5. Over 2, up 10. So as we go up by 1 on the x, we go up by 5 on the y. And that's one way to say it. As we go up, I guess we're supposed to do the independent compared to the dependent. So we could say something like the value of the y values. Say the y values. I'm sorry that I'm erasing, but I have a better way to write this. The y values are 5 times greater than the x values. Now that is not the only way to word that. You could have written something like, as you increase the x values by 1, you increase the y values by 5. You could have written something like that, but this is kind of just an efficient way of writing it. The y values are 5 times greater than the x values. And that's true, because if I multiply 1 by 5, I get 5. If I multiply 2 by 5, I get 10. If I multiply 3 by 5, I get 15. So that's true. And then 4 says, describe a real-world situation that the graph could represent. So we're just going to make something up. It could be something like movie tickets. Movie tickets cost $5 per ticket. And so then the x values would be the tickets, and the y values would be the amount of money. So if you bought 1 ticket, it would be $5. If you bought 2 tickets, it would be 10. If you bought 3 tickets, it would be 15, etc. All right, number 5. Essential checking question. How can you identify the dependent and independent variables in a real-world situation modeled by a graph? So the one thing we got to say is the independent variables, and those are usually they're almost always the y's, depend on and I did that backwards. It's the dependent. The dependent variables y's depend on the independent variables, which are almost always the x's. I'd like to say they're always the x's, but sometimes they get set up backwards on accident. So the answer to this one is the dependent variables, the y's, depend on the independent variables, the x's. Okay, great job. You're done with page 342.